Hello everyone, good day. My name is Vivian Prosper Basas, a Bachelor of Secondary Education, major in Mathematics. Today, I will going to discuss about automorphism. Is any one of you here has an idea what is an automorphism? Clarence, do you have an idea what is an automorphism? How about you, Matmat? Do you have an idea what is an automorphism? Since you don't have any idea what is an automorphism, I will give you the definition of it. So, auto means self. So, an auto is a structure preserving map from a group to itself. Formally, we say automorphism is an isomorphism from a group to itself. Since the domain and codomain of an automorphism are the same, we can compose automorphism and it turns out that the set of all automorphism of a group G forms a group. And this is called automorphism of a group G. And we can denote it like this, out of G. And it's very simple to show that this forms a group. The identity map is clearly an automorphism. Every automorphism has an inverse. That's just the inverse map because it's bijection, and clearly if you compose to an automorphism, you can get automorphism. Several remarks. First, an automorphism is determined by where it sends the generators. For whatever set of generators you want to pick, just fix one. Once you send the generator somewhere, everything else is determined. Also, any automorphism must sense generator. In particular, if G is cyclic or called that, this means that it can be generated by single elements, although there might be a collection of elements which are potential generators. In that case, it determines a set of all possible generators. Example, I claim that there are two automorphisms of the group of integers and their addition. That's denoted C. These automorphisms are the identity mapping and n to its negative, and to see why these are the only two automorphisms. Well, I claim that they've as follows, just these two remarks up there. First of all, automorphism is determined by where it ends generator. Now C of course generated by 1, but it's also generated by negative 1. And these are the only two generators of the integers, so there are two choices for where 1 gets sent. Because it has to send generator to a generator. 1 can either get sent to itself, which is the identity mapping, or can get sent to negative 1, which is the other mapping. So this first automorphism, the identity is just the identity permutation. It sends 1 to 1, and negative 1 to 1, it's negative 1. And the others swap these two. So the automorphism group of integers, since it has a size 2, it is isomorphic. So the cyclic group C2, or you can call it Z2 if you prefer, or you can call it S2 because it's a permutation of two elements. These are, of course, all the same. Next, let's look at the automorphism of a finite cyclic group. We'll do C5. So before, an automorphism is determined by where it sends the generator, as Z5 is of course generated by 1. So in automorphism, phi is determined by the choice of the image of one phi of 1. And there are 4 choices because phi of 1 can be any of the other 4 generators, namely 1, 2, 3, 4, because all 4 of these are relatively prime to 5. So obviously, each of these is distinct automorphism. So there are 4 automorphism of C5, which means that the automorphism group nga na ay order 4. So it must be isomorphic to the cyclic group C4 or the client for group V4. So karon mangutana ko ninyo, asa man ani? Unsaon man nato pag-determine? So huna-hunaa, So I would personally check each of these automorphism and see if any of them generate the entire group in the words of any of them. Nga naa by 4 order. If mauna, then kani nga group is C4. If kung kanitanan nga automorphism have order 2, then it's B4. So for us to understand this further, let's do an activity later on to answer. Other example but not cyclic. So B4 of course is the smallest non-cyclic group, and that's generated by H and V. So this is horizontal flip and vertical flip. So an automorphism phi of this group is determined by where it sends H and where it sends V. These are the generators. Now there are 3 choices for the phi of H. We can send H to itself and send to V, or we can send the other element of order 2, which is HV. Once we do that, then naay 2 choices for where we send V. Well, dili nakasend sa same place as we send H, and dili pwede pod isend paingon sa identify. Therefore, the size of automorphism group of B4 has to be 6. There are only 2 groups of order 6 up to isomorphism. Namely, there's the cyclic group of C6, which is isomorphic to C2 to cross C3. And there is the symmetric group S3, which is isomorphic to D3 as well. So, asa man jud ani ang automorphism group? So, sayon ra i-check. Just take the automorphism D4 and see if they form an abelian group or non-abelian. And now, ato na pong i-discuss ang automorphism of finite cyclic group. First, we need a definition. The multiplicative group of integers modulo n. Sometimes we denote that Cn raised to a star. Or sometimes, ibutangan nato times symbol up here. Although we will usually use this notation U of n stands for the unit, which is term that we all understand when we study rings. This is the group of all integers modulo n that are relatively prime to n, and binary operation is multiplication n. So recall that if we look at integers Cn, sige sila form o group under addition, but wala sila ga form o group under multiplication, because we could have things like this, C4. We might have 2 times 2 equals 4, which is 0, and dili na siya pwede. If we only take the numbers that are relatively prime to n, we never have this issue, and we never actually has a group. And so we denote that as UN. Now let's do some example. First example is U5. So this is the group of these 4 numbers. 1, 2, 3, 4. Mauni sila ang relatively prime to 5. And so mauni karon ang multiplication table. So it's a group of order 4. We can see it's not client 4 group because there are not ones down. So this diagonal. So this has to be isomorphic to the cyclic group of C4. Next example is U6. This is a group of consisting of 1 and 5. Those are the only 2 numbers less than 6 that is relatively prime to 6. So there is only one group of order 2. So this is isomorphic to the cyclic group C2. Next, U8 consists of the numbers 1, 3, 5, 7. These are the ones that are relatively prime to 8. Og sa paglantaw sa multiplication table, makita dayon nato na this has to be the client 4 group. Kay tanang elements na ay order 2 because there's one down the main diagonal. So this is isomorphic to C2 cross C2. So it's not always clear given a number what group UN is going to be isomorphic to, because here's the difference group that have order 4. One of them is cyclic, one of them is not. Quotient that we're going to prove, and it says that the automorphism of Cn which is just of Zn, is isomorphic to Un. So for each element in Un, we can define an automorphism, and let's call it a sigma. So it's a mapping from Cn to Cn that sends 1 to A. So that's what we do in the previous. So we look at the automorphism of C4, so mapping C4 to Z4. What is determined by where it sends 1, and there were 4 possible. There's 1, 2, 3, 4, and that's because there are the numbers that are in the group U5. There are the numbers that are relatively prime to 5, so they are the generator of C4. So similarly, the automorphism group of C8 is determined. So a mapping from C8 to C8 is determined by phi of 1, and this has to be sent to generator of C8, so there are 4 choices, 1, 3, 5, and 7. And composition of this map essentially is just multiplication. The corresponding number, so the actual multiplication table of the automorphism group is what would we get if we had this table, but instead of the numbers, you would put sigma sub the numbers. So instead of this 5 would be a sigma 3, and so forth. So that's why these things are isomorphic. Un is the group of these numbers under multiplication, and the automorphism group Zn is technically the group of this mapping, sigma A, where comes Un. That's all my topic about automorphism, so I hope you learned something. If you have questions, just feel free to message me on my Facebook account, which is Vivelyn Prosper Bases, or you can email me at 25vivelyn@gmail.com. So thank you for listening, and bye for now.